Assalamu alaikum dear students. Today we are going to start as example 7.4 of class ninth. Okay, the question is that a girl purchases a gold crown at a fly's market. After she gets home, she hangs the crown from a scale and find the weight to be 7.84 Newton. She then weight the crown while it is immersed in water and the scale reads 6.86 Newton. Is it the crown is made by pure gold or not? We are going to find out. The given data is given to you that weight of air WA equals to 7.84 Newton and the weight of water is 6.86 Newton and the density of water is 1.00 multiplied by 10 raised to power 3 kilogram per meter cube. Now the required data is density of crown equals to question mark, that a formula is FB equals to WA minus WB, and the second is W by FB equals to a density of object divided by density of water. Rearranging that, we are finding a density of object which is the crown, that equals to a W by FB into a density of water. The solution is a FB equals to a WA minus WB. Putting the value FB equals to a 7.84 minus 6.86 Newton, and we are going to minus that, answers comes a 0.98 Newton. Now put this value in a second one formula and get the value of the density of the crown. Now the putting the value, that is our density of object equals to a 7.84 divided by 0.98 multiplied by 1 multiplied by 10 raised to power 3 kilogram per meter cube, and the answers comes at 8 into a 10 raised to power 3 kilogram per meter cube. So the result from the table of the density of the gold is 19.3 multiplied by 10 raised to power 3 kilogram per meter cube, because the 8.0 multiplied by 10 raised to power 3 kilogram per meter cube is quite less than the 19.3 multiplied by 10 raised to power 3 kilogram per meter cube. The crown cannot be pure gold. Density of crown equals to a 8 multiplied by 10 raised to power 3 kilogram per meter cube. So the crown is not made by a pure gold. Now we are going to do a assignment 7.4 now, that is a geologist finds the moon's rocks whose weight is 90.9 Newton has an apparent weight of a 60.6 Newton when the submerged in water. What is the density of the rocks? Now the question is given to you, that data is given to you, the weight of the water is 90.9 Newton and the weight of the weight of the air is 90.9 Newton and the weight of the water is 60.6 Newton. Density of water is 1000 kilogram per meter cube, and you can change into a scientific figure 1 multiplied by 10 raised to power 3 kilogram per meter cube. Okay, required data is the density of the moon rock. Formula is same as in the example. For finding a moon rock, that density of moon rock equals W by FB into a density of water, but we don't have a FB. First we are finding FB equals to WA by WB. So start the solution and first find the FB, putting the value in this formula and you get the answer of the FB. Now put this one FB in a second one formula and you get the value of the moon's rock. Now the density of the moon rocks is a 90.9 multiplied by 30.0 into a 1 multiplied by 10 raised to power 3 kilogram per meter cube, and multiply and divide it and you get a 3 multiplied by 10 raised to power 3 kilogram per meter cube. It's a 3 in multiplied by 10 raised to power 3 kilogram per meter cube. Clear now? So the answers comes the density of moon rocks. Density of moon rocks equals to a 10 multiplied by 10 raised to power 3 multiplied by 10 raised to power 3 kilogram per meter cube. Clear now? Now we are going to do a example now. Example 7.5. Now the example of 7.5 is the wire of the length is 5.0 meter and the area is a 0.03 meter square, stretch 0.15 meter within the elastic limit. By hanging the weight of 270 Newton, calculate stress, strain, Young modulus of material of wire. So there is given a lot of things to you, that length is given to L equals to 5.0, area is 0.03 meter square, and the extension x equals to a 0.15 meter, weight F, force F equals to 270 Newton. The required data is the stress, strain and the Young modulus. Okay, the formula is stress equals to F by A and the strain equals to X by L, and the Young modulus equals to stress by strain. We have discussed in a lecture also that put the value in there, that stress equals to F by putting the value 270 divided by 0.03 meter square and multiply it as 9 multiplied by 10 raised to power 3 Newton per meter square. The stress we are finding x by L, put the value and simply answers, you get a 0.03. We don't write the formula because a meter meter cuts with a meter and strain don't have any formula. Young modulus is the stress by strain. Put the value of stress, we have find it that a 9 multiplied by 10 is to power 3 put there, and the strain is a 0.03. Clear now? And the answers comes at 3.0 multiplied by 10 raised to power 5 Newton per meter square. So we have find, and the results comes as stress equals to a 9 multiplied by 10 raised to power 3 Newton per meter square, and the strain equals to a 0.03. Young modulus y equals to a 3 into 3.0 multiplied by 10 raised to power 5 Newton per meter square. Clear? Now we are going to start the assignment that an elastic wire of the length 2 meter across sectional area 0.03 meter square is stretched 0.10 meter by the weight by the 300 weight. Calculate the Young modulus of the material. Clear? We have just find the Young modulus. So the given data is L, length L equals to a 2 meter, area A equals to a 0.02 meter square, extension x equals to a 0.10 meter, weight force F equals to 300 Newton. Required data Young modulus y equals to question mark. So the formula y equals to F into L into A into x. This is the stress and this is the strain. If you are don't do like this, first find the stress and then strain, then put the value. So it's a simple to put a F into L and A into x. Clear? When you do this so simply putting the value, start the solution putting 300 multiplied by 2 and a 0.02 multiplied by a 0.10, and the answers comes as 600 divided by a 0.002. So the answers comes at 3 and 5 zeros. So you can shift the point from here to here. The answers comes आपके पास आएगा 3.0 multiplied by 10 raised to power 5 Newton per meter square, and the Young modulus is answer is at 3.0 multiplied by 10 raised to power 4 Newton per meter square. Okay, we have done. Inshallah. Next we are doing in our next display. Okay, Allah Hafiz.